Hello and welcome. It is January 7th, 2026, and today feels like one for the history books. We are tracking what can only be described as a massive tectonic shift in the world of artificial intelligence. Multiple stories broke today that signal a fundamental change in how AI is built, deployed, and maybe most importantly, controlled. So let's get right into it. Think about this. On this single day, Nvidia just unveiled a new superchip that's basically designed to give AI a physical body. At the exact same time, Google and Anthropic are in an all-out war over who can build the smartest AI assistant, and halfway across the world, a regulatory deadline in India could fundamentally rewrite the rules for every single AI company on the planet. This isn't just another news cycle, folks. This is a phase change. You know, for the past few years, we've thought of AI as this thing that lives in the cloud, right? A disembodied voice or a text generator. But today, the entire industry is pivoting from that generative AI to something totally new, physical AI. This is the moment AI starts to really interact with our world. So what exactly is physical AI? Well, the core concept is a huge departure from how we've trained AI before. Instead of just learning from text and images on the internet, these AIs learn about things like gravity, friction, and cause and effect inside these hyper-realistic simulations. They can literally practice a task 1,000,000 times in a virtual world before ever being downloaded into a real-world robot. And that brings us to the biggest hardware news of the day, by far. Over at CES in Las Vegas, Nvidia just launched its Vera Rubin superchip platform, and wow, the specs are just staggering. This isn't some minor upgrade. It's a complete redesign. It's built specifically to power this new era of physical AI, and the performance leap over last year's already amazing Blackwell chip is almost hard to believe. Let's break down what these numbers actually mean. First up, a 5-fold increase in training capacity. What does that mean? It means the Vera Rubin chip can train models with up to 10 trillion parameters. Now, to put that in perspective, we're talking about models with a level of complexity that could simulate an entire nervous system for a humanoid robot. This basically solves the massive data bottleneck that has held robotics back for decades. Next, and this is huge, a 90% reduction in inference cost. Now, inference is the cost of actually using an AI model after it's been trained. Slashing this cost by 90% is a total game changer. It makes running these incredibly powerful physical AI models economically viable on a massive industrial scale. And finally, a 4x improvement in density. That means you need 1/4 of the chips to do the same amount of work, more power in less space. For everything from data centers to autonomous cars, that kind of efficiency is absolutely crucial. So you put all this together, and you see that Nvidia isn't just making a faster chip. They're literally building the entire physical backbone for this new era of AI. Okay, so now that we've seen the hardware, the body, let's look at the software, the brain. With the physical side being taken care of, the battle is shifting. We are officially in what people are calling the Agentic Era, where AI is no longer a passive tool, but an active assistant. And the fight for who's best is heating up like crazy. On one side, you've got Google, which just rolled out Gemini 3 globally. It's built for what they call deep think reasoning and vibe coding, basically the ability to understand what you mean without you having to write the perfect prompt. On the other side, Anthropic's Claude 4 is pushing its extended thinking feature. This allows it to pause a task, go search for new information, and then resume with updated data. So you could ask it to plan a trip, and it could pause, check for real-time flight delays, and then adjust your itinerary on the fly. We're moving from simple command and response to delegated autonomy. But today, the real shockwave came from inside Google itself. A principal engineer there publicly admitted that Anthropic's new tool, Claude Code, replicated a complex system in 1 hour that her team of human experts took an entire year to build. That one admission, it has sent tremors through the entire software development industry. And this really raises the central question of this whole agentic era. What are the economic and professional implications when an AI can compress a year of human meetings, debates, and friction into a single hour of pure execution? Just think about that for a moment. And this isn't just stuff happening in research labs. On the show floor at CES, we're seeing this hardware and software convergence show up in actual products you can buy. AI is moving out of the cloud and directly into our hands. We're seeing AI PCs like the new Asus ZenBook, which has its own dedicated AI processor. Motorola just unveiled Kira, a wearable AI pendant that's like your personal assistant. Samsung's new appliances are using AI to become 65% more energy efficient. And get this, iFlyTech revealed a recorder that does all of its AI transcription and translation completely offline, which is a huge deal for privacy and security. But as AI becomes more powerful and gets embedded in our daily lives, it's of course attracting the attention of governments. And today, we're seeing the beginning of what looks like a global regulatory crackdown, which could really spell the end of the whole move fast and break things era for tech. Right now, all eyes are on India. Today is the deadline for Elon Musk's X to prove it can control its AI, Grok. The Indian government is threatening to revoke the platform's legal immunity, its safe harbor protection, over Grok's ability to generate harmful deepfake content. And this isn't just an issue in India. The UK, France, and Malaysia are all launching similar investigations. And here is exactly why this matters so much. We are witnessing the first major test case where a company could be held fully responsible for the content its AI creates. The outcome here is going to set a massive global precedent. The days of tech platforms claiming they're just neutral intermediaries for AI, well, those days are likely coming to an end. Meanwhile, here in the US, the situation is getting complicated. You have states like California and Texas rolling out their own tough AI safety and transparency laws. But at the exact same time, a new presidential executive order is trying to remove what it calls burdensome regulations to try and spur innovation. This creates a legal minefield for developers who are caught between tough state-level rules and a federal push for deregulation. Which brings us to the money, because the immense, just unbelievable cost of building and running these frontier AI models is reshaping the entire financial landscape, and it's leading to a massive consolidation of power. Today, we saw two huge billion-dollar deals that really tell the whole story. First, the consulting giant Accenture bought the AI startup Faculty for $1 billion to scale up its industrial AI offerings. And then on the creative side, Disney invested $1 billion into OpenAI, licensing its iconic characters to be used in AI-generated video. The big players are just buying up all the talent and all the content. And here's the number that explains why this is happening. OpenAI is projected to spend $115 billion by 2029, and that's mostly just paying for the servers to run its models. This burn rate is so astronomical, it's fundamentally changing who can even play in this game. So what's the consequence of that massive cost? Well, analysts are now saying that promising AI startups are dying at Series A. They simply cannot afford the computing power to compete with the massive server farms being built by Google, Meta, and Microsoft. This isn't a race that just anyone can enter anymore. Only a handful of global entities have the resources to even stay on the field. So when you connect all the dots from today, the shift to physical AI, the rise of these autonomous software agents, the new regulatory reality, and the massive economic consolidation, one conclusion becomes crystal clear. AI has moved past the experimental phase. It's no longer a novelty. It is rapidly becoming an operational necessity for every major industry on Earth. And that leaves us with one critical question. As these systems become autonomous, operating our factories, writing our code, even running our home appliances, who or what is ultimately in control? Thanks for joining us for this explainer.